Imagine this. A small town wakes up one morning to find that every single street lamp has stopped working. People immediately start guessing. Some say it must be a coordinated cyber attack. Others insist it is the work of a mysterious hacker group. A few even whisper about government experiments or cosmic signals from outer space. But then, an elderly electrician walks calmly through the crowd, opens a single power box, and finds the truth. A squirrel has chewed through one wire. Just one. No conspiracies, no secret organizations, no cosmic messages. Just a squirrel doing squirrel things. And in that moment, the town learns a lesson older than modern science itself. Sometimes, the simplest explanation really is the right one. This is the spirit of Occam's razor, a principle that quietly shaped philosophy, science, medicine, and even how we make everyday decisions. It tells us that when we face competing explanations, we should prefer the one that requires the fewest assumptions, the least mental gymnastics, and the most straightforward logic. In our world full of complexity, noise, and overthinking, Occam's razor isn't just an abstract idea, it's a tool, a mindset, and sometimes even a relief. It invites us to step back, breathe, and ask, what if the answer is actually simple? Occam's razor, sometimes spelled Occam's razor in various sources, is a logical and philosophical principle suggesting that when two competing ideas attempt to explain the same phenomenon, we should prefer the explanation that relies on fewer assumptions and avoids unnecessary complexity. Although versions of this idea have been echoed by influential thinkers such as Albert Einstein and Isaac Newton, the principle is most widely associated with William of Ockham, a 14th-century Franciscan friar from the village of Ockham in southern England, who articulated the formulation that has survived into modern discussions of reasoning, science, and problem-solving. Today, this principle serves as a practical tool for simplifying the way we interpret events, make decisions, and analyze the world around us, because the metaphor of the razor symbolizes cutting away the excessive, the speculative, and the redundant elements between two hypotheses, allowing us to reach a cleaner, more economical conclusion. It has become a foundational method in both scientific inquiry and everyday thinking, encouraging us to favor clarity over complication, efficiency over confusion, and direct reasoning over intellectual ornamentation. Although William of Ockham is remembered primarily for the methodological principle that now carries his name, his contributions extended far beyond this single idea, reaching into the fields of logic, physics, and theology. As one of the most prominent defenders of nominalism in medieval philosophy, his work influenced the course of scholastic thought and helped shape what would later evolve into the modern scientific method. His famous guiding maxim, often paraphrased as, "Do not multiply entities beyond necessity," continues to act as a reminder that simplicity, when justified by evidence, is not merely elegant, it is profoundly effective. Imagine you are driving after a long, stormy night, and you suddenly come across two fallen trees blocking the road. There is no obvious sign explaining why they collapsed, no burn marks, no vehicle tracks, nothing out of the ordinary, and in such a situation, the most straightforward and reasonable conclusion is simply that the trees were blown over by the storm. A conclusion that feels entirely adequate for most people, because it aligns with what we already know about strong winds, heavy rain, and the natural fragility of aging trees. Yet for some individuals, this plain explanation lacks excitement or mystery, and they might instead propose that the trees were knocked down by a pair of twin meteors arriving simultaneously from the depths of space, striking the ground at precisely the same moment, only to collide with each other instantly afterward and completely disintegrate without leaving behind a single trace. Of course, such a scenario is not impossible, but it demands a long chain of extraordinary assumptions that have no evidence supporting them. This is precisely where Occam's razor becomes relevant, because the principle tells us that when two competing theories appear equally capable of explaining a phenomenon, we should choose the one that introduces fewer assumptions and avoids unnecessary complexity, meaning that the simple and direct explanation, the storm toppled the trees, is far more rational than the extraordinary meteor hypothesis built on layers of speculation. Occam's razor does not suggest that the world is simple or that scientific questions always have easy answers. Rather, it reminds us that while science often leads to complex and nuanced explanations, we should resist the temptation to add extra assumptions when they are not required, maintaining the clarity of our reasoning by keeping our explanations as abundance and evidence-based as possible. Because even in fields where answers grow intricate, the principle remains a guide, urging us not to multiply causes, entities, or mechanisms beyond necessity, preserving the intellectual discipline that makes logical and scientific thinking effective. When you find yourself wrestling with a complex problem that seems to grow heavier the more you think about it, invoking Occam's razor becomes a powerful cognitive tool because it reminds you that simplicity, far from being a naive or superficial approach, is often the path that leads most reliably toward clarity, accuracy, and practical decision-making. This principle plays a significant role in how we evaluate choices, design reasoning processes, and navigate uncertainty. For instance, when two computer programs are capable of performing the exact same function, choosing the shorter one is typically the wiser decision because fewer lines of code usually imply fewer opportunities for bugs, less structural fragility, and a smoother path for troubleshooting, which ultimately demonstrates how simplicity directly contributes to stability and efficiency. A similar dynamic appears in medicine, a field where Occam's razor quietly guides diagnostic reasoning every day. When a patient complains about nasal congestion, it is far more reasonable for a physician to suspect a common cold before considering a rare and exotic immune disorder. Not because rare illnesses never occur, but because the simplest hypothesis that aligns with common patterns is statistically the most probable starting point. The same logic extends into the realm of argumentation and critical thinking, where the strongest argument is not the one decorated with unnecessary assumptions or speculative layers, but the one that requires the fewest additional claims, the least amount of unverifiable information, and the smallest number of moving parts to stand on its own, meaning that simpler theories are not only easier to test and verify, but also carry a lower risk of hidden errors. In this sense, Occam's razor becomes more than a philosophical principle. It becomes a disciplined way of thinking that pushes us to cut away mental clutter, resist seductive but complicated explanations, and focus on the solutions that are clean, coherent, and most grounded in observable reality. Occam's razor also appears vividly in modern storytelling, and one of the most memorable examples is the 1997 film Contact, which blends science, philosophy, and existential wonder in a narrative that questions how humans interpret the unknown. In the film, 1997 Jodie Foster portrays Dr. Ellie Arroway, a dedicated scientist working within the SETI project, and after years of patient listening, she finally detects a mysterious signal emanating from the star Vega, a discovery that she painstakingly decodes only to find an extraordinarily detailed set of schematics for a highly advanced transportation machine. Once the machine is constructed according to the alien blueprint, Ellie enters it and begins an experiment that, at least from her perspective, transports her through wormholes to a distant corner of the cosmos, an experience filled with emotional intensity and profound beauty. Yet when she returns, she discovers that no time has passed on Earth, that no external measurements have recorded her departure, and that the only traces of her journey appear as meaningless static in the devices that were meant to record everything. As Ellie tries desperately to defend the reality of her experience against skeptics and political pressure, Occam's razor is invoked as a guiding principle, suggesting that the simplest explanation, that she never went anywhere, and that the entire episode occurred solely within her mind, should be preferred over elaborate theories involving interstellar travel and extraterrestrial engineering, which naturally raises the question of how far simplicity should be taken as a rule when dealing with extraordinary claims. However, the narrative becomes more complicated when investigators later discover that the static recorded during her supposed journey lasts precisely 18 hours, a duration that aligns with her personal account and strongly implies that something happened which the world's instruments failed to capture, thereby illustrating how Occam's razor, though immensely useful, does not guarantee absolute truth and can even mislead when applied too rigidly to phenomena that may exceed our current scientific understanding. Through this twist, the film invites viewers to reflect on the limits of human perception, the boundaries of scientific explanation, and the possibility that reality is sometimes more intricate than our simplest hypotheses allow, reminding us that while Occam's razor encourages clarity and economy of thought, it must be wielded with humility, especially when the universe presents mysteries far greater than our existing tools can measure. While Occam's razor offers a powerful mental shortcut, it is not without limitations, because relying on simplicity to validate or dismiss an explanation carries two fundamental problems. First, deciding whether a theory is simple is inherently subjective and depends heavily on the interpreter's perspective. And second, simplicity alone never guarantees truth, since a theory may be elegantly minimal yet still completely wrong. The world operates within a web of deeply interconnected and dynamic systems, meaning that many phenomena cannot be reduced to a neat, uncomplicated narrative. And for this reason, Occam's razor should never be used as the sole criterion for choosing between competing explanations. After all, scientific methodology is grounded in empirical evidence, and William of Ockham himself never claimed that simplicity should override observation or experiment. Choosing the simpler account over a more complex one can certainly make reasoning more efficient, and in many situations, it provides a practical starting point that helps us organize our thoughts. But this approach does not always guarantee accurate conclusions, because sometimes the truth lives in the details, hidden in those subtle complexities that simple theories tend to overlook. And furthermore, the very concept of simplicity lacks a universal definition, since the laws governing the universe are not necessarily crafted to align with the limits of the human mind. And yet, despite its imperfections, Occam's razor remains an invaluable tool precisely because it helps us decide where to begin our analysis. Scientists choose to test the simplest explanations first, not out of naivete, but because simpler hypotheses are easier to examine, easier to falsify, and quicker to confirm or discard, ultimately accelerating the journey toward deeper understanding. In the end, Occam's razor does not promise certainty. What it offers instead is orientation, a clear starting point in the often overwhelming landscape of possibilities, and a reminder that while the universe may be infinitely complex, our search for truth becomes more meaningful when we learn to cut through the noise, remove unnecessary assumptions, and approach every mystery with both disciplined simplicity and intellectual humility.